All good. Recording, cloud recording on, sound on, and Camtasia SD recording is also on, right? Okay, let's open up IntelliJ. Let's get started. So, last session of the week, right? I'm sure that you guys are, getting into the reactive programming right now, reactive stream, the way it works. We kind of started learning all these things, and I'm sure that you guys will find some time this weekend to practice, and I'm sure in some way I'll be able to provide you something so that you guys can practice. Okay. And in next week we'll go more deeper into the reactive stream. If you could have asked me to start reactive straight away for a KT, my company, I might have start with the session that I will be teaching you in the next session. Okay. But all these 6 sessions are just to have a kind of foundation, like what is what, so that we will not we'll not get lost with the words, the fancy terms. And I think we are handling it well right now. I'm pretty happy that you guys are understanding, answering things, asking me questions on different things. So what I feel that you guys are able to relate to things right now. Okay. So let's just work on a couple of things right now, and these things are going to be very, very crucial in your from the next session onwards, whenever we'll be starting the serious reactive code. Okay, couple of charts, let me read that, but guys, feel free to ask me questions rather than putting it on the chat. Roll camera. Why this is last live? This is not last live, Mahesh. Last live for the week. So we have more lives coming off on reactive. Okay, and I've decided to take maybe 6-7 more sessions on this topic before we jump into the Spring webflux, and from there we can take on with reactive microservices. Okay, now let's just come back to Earth, because we are on Moon right now. Reactive microservices, Spring webflux is too far away. But yeah, right now in your Office application, if you guys are using Spring framework, you can go and you will start to understand different things. I think within the next couple of sessions, a lot of things will start making sense for you, even though you haven't done any coding in reactive Spring or something. Okay, but yeah, let's just continue with our reactive Java thing right now, and we'll get into those things later. So coming back, so I will start the session exactly where we left. I remember Sham asked me a question yesterday, and I think Sham, you are online over here. So you asked me the question, like, Avilash, you have a couple more slides you wanted to show on Backpressure. We will start from there. Let's just see the same example that we have seen in the last session very quickly. Imagine I'm a content creator and I'm publishing content, okay? And I'm Selenium Express. So it's I'm publishing some kind of tech contents. You can think like that. And let's say there is this guy, his name is Amit, and he is my subscriber. He wants to be my subscriber, okay? He wants to consume the data that I produce, okay? So he sends a subscription request to me that I want to subscribe to your Spring course, and here is your course fee. And then I say, okay, all good, subscription successful. Then you know that when the publisher or this content creator, being a producer, need to give some way to the subscriber in order to make sure that he's a valid subscriber. Okay, so upon a successful subscription, I say, okay, done. This is your account details, and using this account details, you can communicate with me right now. Okay, and that's the proof that this is a successful subscription. Okay, and here I, as a publisher, approved this account and give this account object to the subscriber. Now the subscriber can request me data, right? So it can ask me data. He can ask me data in different way, right? He can ask me data like this. give me all your lessons. Okay, I paid you the fees. Now you give me everything that you have. Now, this publisher, okay, does have already a lot of contents. Okay, the publisher starts pushing the contents right now. Hey, here goes the lesson 1, here goes the lesson 2, here goes the lesson 3, and like that, the creator keep on pushing contents, okay, to the Amit, who is the subscriber. Now, once the subscriber asks that give me all the contents to the publisher will be start pushing all his contents. The publisher might be too fast, right? He might have a lot of contents. He will start pushing all the contents. Hey, here goes the lesson 1, here goes the lesson 2, here goes the lesson 3, and here goes the lesson 4, something like that. And this subscriber is a beginner. He's a fresher. Imagine he's new to the tech industry, and it will take him some time to process the data, isn't it? Because he might not be able to catch up as quick as you guys, right? Let's say you guys having 5 years, 10 years, 12 years of experience. So you guys can grab my contents too fast. You guys can ask me, okay, Vilas, get me contents. And as soon as I'm pushing the contents to you, you're also consuming it because you are very fast in learning. But this is a slow consumer. Imagine he's a fresher, a beginner. He is not able to process all the contents that I'm giving. Let's say I'm giving lesson 1 to him. He need to finish lesson 1 first in order to consume lesson 2, right? And once I push lesson 2, he need to finish that first before consuming lesson 3. So if the producer is too fast and pushing data too fast, then there might be a chance that the Amit, being the consumer, may not be able to process the data the producer is pushing to him. And here goes a very big problem, right? And to sort out this problem, we have the concept of backpressure. The rate of pushing the elements from the publisher end is very fast, and the subscriber is not cope up with that. And if the subscriber feels that, it can ask the subscriber can ask the publisher to slow down. Okay, and that's what we call backpressure. Amit, being the subscriber, may have control. I'm giving a star mark. May have control. The publisher may listen to Amit, may not listen to Amit. You are asking me that, Abhilash, slow down your lessons. Why should I? Or I should say, I should, because I care for you, right? So there might be two types of publishers who care for the subscribers, who doesn't care for the subscriber. That's what we call hot and cold publisher. We'll be going into that later. But right now, imagine this is a publisher and the subscriber is saying, okay, I'm not able to, handle your data, so slow down a bit. Okay, the publisher right now can listen to the subscriber and can slow down and keep pushing the elements in a slower manner that the subscriber can process. Okay? So now, imagine, see this diagram right now. Now what the subscriber can do, the subscriber can ask the publisher that, okay, give me one lesson. The tech content creator gives him one lesson only, that, okay, here is the lesson 1. The subscriber right now processes that and asks again using this account. Obviously, this account is the subscription object that the publisher has given to the subscriber. And using this object again is requested for one more lesson. Give me one more lesson. Now the publisher again pushes one lesson to the subscriber. Okay. Now we can see this arrow is going through this subscription object, but it's not required. The subscription object, this account is only needed for the subscriber whenever it requests for data to the publisher. Okay. And the publisher is pushing and directly notifying the subscriber and giving the lesson one by one, and it can keep on asking lessons for one, and one more lesson will be returned from the publisher. Not returned, it will push, the publisher will push one more lesson to the subscriber. I hope this makes sense. Or the subscriber can also say, okay, you can give me 3 lessons of yours and let me process those things first. Okay. It's also a backpressure control. subscriber is asking right now, okay, give me 3 relations. Then the publisher will say, okay, here goes the relation 1, here goes the relation 2, here goes the relation 3. Process it first. Now the subscriber will process them, and once it's done processing all the elements, it can ask again, get me 3 more lessons, something like that. And again, the publisher will keep giving 3 more lessons. Now, here goes the main thing. Backpressure is the ability for the consumer to signal the producer that the rate of emission is too high. Okay? The backpressure is the way the consumer can tell the producer that, okay, you are too fast, buddy. You just slow down a little bit. Okay? It's a signal from the subscriber to the producer, from the subscriber to the publisher, that I need this much of data. Give me that only. Don't give me all your data. I don't need that. Whenever I'll ask for it, you give me that. Okay? I hope this things makes a little bit of sense right now. And now you have seen some way doing the things yesterday, but I don't want to again, open up yesterday's thing. I'll quickly create a new package because I don't know like who attended the last session, who didn't. So I'm going to say Reactive 3. Okay. And here I'll create a new class quickly. Let's say Reactor 3 practice or something like that. Okay. And I'm going to say main. Okay. And I need a producer here, a flux here, which can emit 0 or n elements. So maybe I'll go to my yesterday lesson. I'll just copy one flux, guys. So excuse me for that. Yeah, maybe I'll copy this line only. Okay. So now you don't need to worry about like I'm copy pasting the code or something like that. Okay. So let's say this is a publisher I'm creating, which is a flux, right? So I can import it. Okay. So this is a flux. Right now, this is a publisher. Now, if I'm going to do Command Option V, it's going to return a string flux. Okay. So now what I want, let's say I want to ask, I want to subscribe first. Let's say string flux dot subscribe. And for now, I just want to consume it. So I'm going to say word and s out of word. Something like that. You have already seen that. No need to explain this. So it's going to consume all the elements, right? You can see now everything has been pushed over here from the publisher to the subscriber, and everything makes sense right now. Now, I told you one way the subscriber can ask data to the publisher. Okay, and we have one overloaded method of the subscribe that I was showing you yesterday. This is your onNext behavior, and I think you can also give your for error also you can add a hook. You can also add a hook for your completion event. And at last, I think this deprecated method, if you want to use, this is going to give you access for the subscription object. So you can take the subscription object and you can say subscription.request and get me only 1 elements, okay, or something like that. I only want 1 elements right now from here. Now the subscriber who is subscribing to the flux is asking for only 1 element, and you're getting 1 element only. So here what I want to say, in the subscribe method, I'm passing a subscription object over here and I'm doing a request, right? So if you're going to go to the subscribe method, look at this method. As I said, it's a deprecated method. This is not the right way to ask, like this is your backpressure control. You're asking only 1 element from the subscriber, okay? So this is not the right way to do, but you can see in this method, you have the subscription consumer, and this like you can see this interface, right? This is subscription interface. The subscription object, whenever you are getting from the publisher, you have 2 methods over here. One is called request, one is called cancel. Using the request method, you can pass the number as many events that you want to receive from the publisher. You can specify that. Okay, so I'm creating another consumer over here, and I'm just having a request call and just passing in 1 over here. If you're going to pass in 2, you're going to be getting 2 objects from the subscriber. But as I said, this is not the right way to do the things, right? So let me run. Now I'm getting 2 events from the publisher pushed. Okay, But what is the right way to do the things then? Why this is deprecated, right? This fourth method is deprecated. This is another flavor of the subscribe method. So how to fix that? Maybe what you can do, you can give your own implementation. Okay. So how to give your own implementation? I told you, you can create your own subscriber. But the problem is, like, if I'm going to create my own subscriber, let's say class, let's say my subscriber new, or let's say word subscriber, my word subscriber, or word subscriber. I'll say word subscriber. Okay. And that's implements subscriber. If you're going to do that, you need to override all the methods that you have inside this interface, isn't it? And you know that there are a lot of methods like onSubscribe method, onNext method, onError method, onComplete method. You need to override all this method. Okay. And here, you know, the onSubscribe method will be called whenever the publisher first try to subscribe to the subscriber. It will call the onSubscribe method, gives a subscription object, and using the subscription, you can just do s.request and can ask the data, like how much data that you need. But I don't want to implement all these methods, right? So what I'm going to do, I'm going to remove all this thing. Okay. Instead of using the subscriber today, maybe I can use something, an abstract class. Okay. I'm going to say extends base subscriber. Okay. You can see there is a base subscriber coming from core Reactor core publisher. Okay. And I'm going to say, this is my base subscriber. And the good thing is you can see it's an abstract class. So all the methods of subscriber has already been overridden over there. And that's why I don't have to do anything. Okay. It's not giving any compilation error. So if you're going to see the base subscriber here, that implements the core subscriber, and the core subscriber internally implements the subscriber. Okay. If you're going to implement directly subscriber, you have to give implementation for all this. I'm not doing that. I'm not even implementing the core subscriber. There's a base subscriber, which has a lot of methods they have already implemented. Let's see, onSubscribe method, onNext method, already the implementation is there. Now what I want here, I want the backpressure control. Okay, that's why I'm creating this subscriber, so that I can just do new word subscriber over here, like this. Word subscriber. Okay, this subscriber will be used right now. So I will do one thing. I'm going to do command N. I want to override method from that abstract class, and I want to override the first method, which is called, which method will be called when the publisher, how publisher says to the subscriber that your subscription is successful. What method I have to override? Just see. In the base subscriber, there are a lot of methods. What method do you think I have to override to make sure I need to have a hook when the publisher
hook finally signal type
finally. I need to repeat my question one more time. Maybe it is misunderstood. Let me complete my question. My question is when the publisher finally makes sure that everything goes right whenever the subscriber requests that, okay, I want to subscribe. The publisher says, okay, now the subscription is successful. How the publisher will tell the subscriber that the subscription is successful?
Who can subscribe?
Who can subscribe, right? So this method I override. It's the onSubscribe method only. Hook means it's a hook method, right? It will be called by whom? The publisher, right? It's a hook method. Okay, I'll remove the implementation. I'll change the implementation right over here. So what I want to do, so this method will be called, right? So whenever the subscription, successful, let's say subscription successful, okay? And you can see it is also giving you the subscription object. The publisher will create that and will give it to you. Now, if you're gonna run this, okay, you're gonna be getting this thing on the console. My system started slowing down a little bit, so you have to bear that for this session. So I think you can manage, right? So now the subscription is successful. Now we need to ask for data, okay? The subscriber need to ask for data. So how to ask for data? So now yeah, exactly. Subscription, not on next, subscription.request. If I'm going to do subscription.request, and if I'm going to ask for everything, then I told you how to do that. I told you to use the long.max value, right? So if you're going to do that, run this. Okay. So you can see subscription successful, but you are not seeing all the data. How to see all the data? Maybe I need to override the onNext method, right? Because the onNext call will be coming from the publisher to the subscriber. So onNext, we can see hook on onNext where it is. There you go. And here I just want to say sout data received. Okay, sout, let's say data received, and let's say the received data is the value. Okay, now it will give me all the data, right? So if you can see over here, if I'm going to run this, so it should give me everything that we have. Okay, the onComplete is also going to come from the publisher to subscriber, but I haven't overridden that particular method. That's why it's not showing you any log over here, but you can override the onComplete method over here as well, the hook on onComplete, and that will, you can log anything that you want over there. But right now I don't want all the data. I want only one event to be pushed from the publisher to subscriber. Then you can just do this, subscription request 1. If you're going to run this, whenever you subscribes, right, whenever the subscription is successful, you are asking the producer that, okay, just give me only one element. Okay, and now the producer is going to call the onNext method and going to pass in one elements over here. Look at that. The subscription is successful, the data received, and only one data has been received. Now, once I process one data, I want to ask for one more data. Okay, so what I can do, I can again do subscription.request again. After I process, okay, on the onNext method, I'm going to ask for one more data again. Okay, but the subscription, this variable I don't have access to. So I'm going to copy this variable, declare it over here, wrap it off, give it the type. The type is subscription over here. And right now, how to initialize this? Otherwise, this will throw me null pointer exception. But this will not throw me null pointer exception. Why? Because this object I received over here from the publisher. Whenever the publisher will call my subscriber, it will also give the subscription object. So that object, first I will set it, this dot subscription is equal to subscription, right? Now this will no longer be null. So I can use this over here as well, right? Now what I'm doing, upon the successful subscription, I'm asking for only one data. Okay, you can ask for 10 data also over here, but I'm only asking one event. And whenever that event will be processed, the onNext method will be called. Okay, once I process that event, I'm asking for again one more data. Okay, then again one request will be go to the publisher, and the publisher will call the hook on next method. Now again I'll be processing the data, and I'm again going to ask for one more data, and this continues. Okay, so if I'm going to run this, you can see one by one I'll be grabbing everything over here. Okay, and obviously right now there won't be any more data on the publisher, so it sends a complete event. As I told you, the publisher also can send complete event as well. If I'm going to do override methods, hook on complete, and here I can just have a log over here if you want, sout, let's say completed. Okay, we're going to run this. Okay, it'll see the complete event over here. Okay, so I think you understand, right? So if you want, you can also ask for 10 events right now. Okay, what does it mean? It means that, okay, whenever the subscription is successful, I need 10 events. Okay, and then the hook on next will be called again, and every time the hook on next is getting called, you're processing the data, again you're asking one more element, right? So before even processing all the 10 events which are coming to you, in every call you're asking for one more events over here. Even though if you're gonna comment this, just see what is going to happen. Do we have, let's just see over here. You can see I don't have, I have only 1, 2, 3, 4, 5, 6, 7. 7 events are over here, and after that we don't have any events in our publisher. So it's just saying completed. Okay. So I don't even need to have the request over here, but you should not do that. Let's say you are asking for one, okay. You're asking for one event, and every time you're processing, you can ask for, okay, let's say I'm processing one, then, I'm asking for 3 events more. Okay. So if you're going to do this, so in the first call, the call will be over here. It will print the value. Then again, it will ask for three more events. Okay. Then again, it will print something and asking for 3 more events, right? You can also do that in that way. Okay. You can put any numbers over here. Okay. And I think this makes sense. Okay, guys, so in this way, what I'm doing the backpressure control. As I said, backpressure is the ability of the consumer to signal the producer that the rate of emission is too high, just slow down a bit, and only give me those data, only give me that many events that I'm asking for. Okay. And you see the request method of the subscription API, and you know how to handle that thing right now. One last thing. Yes. Yes.
We are not slowing down, right? Like we are just getting data one by one. If there is any delay, you can introduce them.
No. You are slowing down. You are slowing down. How you are slowing down? Because the latency. There is something called a latency. Okay. Yeah. The producer.
Milliseconds, right? Because we are not controlling that latency here.
So the producer can send elements very fast, very, very fast. Right? Or the producer may be a slower system. It may not send you elements that much faster as well. But it is fast or not, who will decide? The subscriber will decide. Let's say producer is some kind of a stock market producer, or maybe some currency converter producer where the currency value changes in every hour or every second. For an example, stock value, in every second it will change, or the Bitcoin price, every second it will change, right? So it will keep on generating too fast data and keep on publishing all those events to the subscriber, and the subscriber is right now not able to process it. So once the subscriber, it doesn't matter how much, what is the latency. The latency means what? The latency means the time the producer start emitting the data and the time the subscriber start receiving the data. Okay, that the time difference between that, right? So basically, that difference we can control to the subscriber. The subscriber can ask producer that, okay, it doesn't matter to me, like, how much data you have, how fast you generate the data. Only give me 10 elements. Only give me 3 elements. Next time I'm gonna ask you again 2 or 3 elements. You don't need to send me all your elements, in a very rapid speed. Okay. Okay. There are so many questions. Yes.
I have one question. Right?
Yes.
In only. Here, like hook on next, we are requesting, right? So we are again suppose here initially while subscribing, so we are like subscription.request of 1, and next. So you are in the next call. Hook on next is for the next element after printing the next element. So we are again requesting.
Yes, exactly.
But for the another next element, we are again requesting 3. Is it not a kind of redundant multiple times, like?
No, it's just like you are taking one lesson from me, Swati, and you're asking me, okay, well, get me 2 more sessions. Then in the next call again, you're asking me 2 more sessions. Like it's up to the subscriber. The subscriber is right now may want to ask the data in advance to the publisher so that it will have some kind of buffer time to process those data, isn't it? But yeah, I'll showcase this scenario, Swati. This scenario and the thing that Mahesh was asking, do we have more control? Okay, we'll get into that. Okay. But yeah, for now, I just want to show that this request method. Okay. So we will be able to request for data using the subscription object. Okay. That's the only thing that I want to hear right now. There's one more question from Arbaz. The hook on next having subscription 3 for the next 3 elements received. Would not we end off calling 3 more elements? Yes. That's what I was trying to say. So do we have to maintain any count before asking for another 3? No, we don't have to. We don't have to. It's just some kind of events which will be published. I'm just controlling how many events that need to be published, right? Don't get lost with this. For now, just make it one-on-one. Okay, till the time I'll, I will go into those topics in more detail. But for now, one more thing you can do, and I'll come back to all of your questions, Mahesh, Swati, or Baz, right? Valid questions only. So we'll come back to this. Now, the thing is, okay, one more thing, guys, you can do, instead of doing subscription.request, instead of doing all this thing, okay, you can also do, you don't need to do this. Let me remove everything. Let me remove everything from here, okay? So whenever the subscription happens, that you can directly use the method called request over here, okay? And you can ask one instead of doing subscription.request. Why? Because this request method is coming from this best subscriber. They already have a good implementation. You can see, they are doing, creating the subscription instance over here, setting up the subscription instance and requesting over here. Okay, so you can utilize this request method directly, and every time you're requesting, you can also request over here. Okay, so first time whenever the subscription happens, I'm first requesting, I'm asking the publisher to get me the data, and then every time this method only will be called, and every time this method will be called, I'm processing the data, asking for one more data. Again, this will be called processing the data, asking for one more data. Okay, I hope this thing makes sense. And let's say you can also cancel the thing. For an example, I'm going to say, if this is not a very good example, but just want to showcase the method. So see, I'm going to say, once I get this word called world, once I get this word, let's say if the value dot equals world, whatever I have copied, I'm going to say subscription dot, do I have a cancel method? Yeah, I do have a cancel method over here. I want to do cancel. Okay. So I want to cancel the subscription if it is world. Then what will happen? Look at that. If I'm going to run, all this data will not come right now. See, after the world is printed, I have canceled. I've done the cancel request over here. So once it prints the data, okay, even after canceling, if you're going to keep on requesting, nothing will happen. Okay, you got the world over here. Okay, let's say world value is coming, and I'm printing it obviously. And before that, I've given a cancel request. Once I say cancel, means it's cancel. Okay. After that, if you're going to keep on requesting again, I won't be getting the data from the publisher. Okay. So you can directly use cancel. What is this cancel? If you have question, again, this is a method. Okay. They have, maybe internally, they might have making call somewhere. Hook on cancel. Okay. Maybe, I don't know, like where they have given the implementation. Let me do like, what do you mean by cancel? The cancel means, okay, I told you I have a subscription object, right? Let me put it over here one more time. Okay. And I can say this dot subscription, and I can set it, the subscription object that I'm getting over here. And inside this subscription interface, I have two methods. One is called request, one is called cancel. I told you that so the subscriber is going to use the subscription object to talk to the publisher. It can request for data, or it can cancel the data, right? Or it can cancel the subscription. For an example here, using the subscription, I can also do, instead of saying cancel directly, this is a method developed by the best subscriber. I can just do subscription.cancel like this. Okay. This exactly means the same. Okay. I'm canceling the subscription over here. And once I cancel, I won't be able to receive the data. Okay. Make sense, guys? At least whatever I said, or you have any questions on that? Abhilash, if some error comes in hook on next, will it be auto cancelled? Yes, we have seen that kind of scenario yesterday, or was once any error happens, means you'll automatically go to the uncancel method, right? If some error comes into the hook on next, will it automatically get cancelled? Obviously, it will be cancelled, right? So just check this one, guys. So what we have learned so far from the last few sessions. we have a iterator pattern we have learned. Okay. So in the iterator pattern, what we have seen, we have a client, we have a source. The client is calling the next. Who is calling the next? The client. It's a pull model, right? The client is asking for data by calling the next. The source gives him one value or one data. Again, the client need to process that data. The client doesn't know how much more data the source has, isn't it? Again, the client keep on calling the next. The source will keep on giving the data to the client. Okay. So this is how the processing happens over here. The source might have a stream of events, a stream of data, or stream of objects that is trying to process to the client, but one by one manner. Okay. But the client doesn't know if the source has run out of data. If the source might have run out of data, client again will make a call. If there is no data, the source will give null. Okay. So this is what we learned in the iterator pattern. The data processing happens in a one by one manner. Okay. So the consumer here synchronously pull items from the producer one by one. Isn't it? In the iterator pattern, synchronously means one by one. Okay. Nothing fancy is happening over here. I'm asking you one thing, you are giving me one thing. I'm asking you one thing, you're giving me one thing. Okay. The producer sends an item only when the consumer requests for it. If you won't be requesting for the item, you won't be getting it. Okay. In the iterator pattern. Now let's just talk about the observer pattern that we have learned. Okay. In the observer pattern, we have learned we have an observer, we have a subject or a publisher or an observable. The observer, first of all, request to the subject that, hey, I want to observe you. Okay, so the observer, first of all, register itself with the subject. And then the subject will push the value or notify the value to the observer whenever the data is ready. Right? Something like this. So it's a push model. The subject will keep on pushing the notification to the observer by hitting the update method of the observer whenever the data is ready or whenever the new data arrives in the subject, or the data over here can arrive anytime, right? And whenever the data changes, whenever something happens over here, it's noticed the observer by calling its update method and passing in the data whatever changed. Okay, so here the observer is just requesting, but the subject or the publisher is pushing data. Okay, unlike the iterator pattern. In the iterator, the observer was pulling the data from the subject. In the observer pattern, the publisher is pushing the data to the consumer, okay, or to the client. Okay, we can also have some methods right over here like delete observer. If the observer wants to delete, deletes itself from the subject, it doesn't want to observe it anymore, it can also have some utility features like delete observer. So one or many subscribers can subscribe to the publisher events in the observer pattern. The producer asynchronously pushes events to all the subscribers as soon as it generates the data. And I told the data can be generated in the publisher at any time. Okay, so whenever the data it has, the publisher has, is gonna make an update call to the client. Okay, so the client is not blocked. Let's say you are my subscriber. Okay, you have taken a course from me. Am I gonna tell you, okay, you sit at your home and keep on waiting for my video? Okay, don't do anything. Keep on waiting for my video. Keep on waiting for my session whenever it happens. Let's say I have a session is going to happen. Let's say at 7 o'clock, you don't do anything. You keep on waiting for my session. No, you are not doing that. Okay. Whenever the session happens, I'm pushing an update to you that, guys, the session is going to happen. You are not blocked. You are doing your own work. You are roaming around. You are doing your office work. You are having a lunch, dinner, sleeping, doing your work. And whenever you get an update from me, you are coming and doing something. Right? So it's an asynchronous push. I, being a publisher, will update you whenever something I have. Okay? And you're going to be reacting to that only. Okay? You are You are not blocked. So it's a asynchronously push. Okay. Whenever I have something, I'm going to push. Okay. So you don't have to be, keep on waiting for me. Okay. Now we're going to see something called another pattern called reactive extensions. Well, what is this reactive extension? You can think like this is the father of reactive stream, the thing that you are learning right now. The reactive extension is the first initiative for reactive programming. Okay. This is the parent of all. Okay. I think it's created by Netflix or Microsoft. I'm not sure. But the first leverage the Java people has, I think RX Java has given the implementation to this at first. Okay. And right now we have a lot of improvised version of this, what we call reactive stream. But this came first. The reactive extensions came first. It's exactly same whatever you have learned. It's a combination of your iterator and your observer pattern. Okay. I'm going to show you how. See, you have a subscriber, you have a publisher. The subscriber wants to subscribe. So it's called some kind of a subscribe method of publisher and make himself subscribe to this. The publisher, upon a successful subscription, creates a new subscription object. Okay. And hands it over to the subscriber. And now the subscriber, obviously it will hands it over by calling the onSubscribe method. But it will pass the subscription object that it is creating and give it to the subscriber. Something like this. And now the value from the publisher will be pushed using the onNext method like this. Okay. But there is no request you can see over here. Okay. It's directly pushing the value. It can also push the error event. It can also push the incomplete event. It can also, the subscriber can also unsubscribe because we have given the subscription object to the subscriber. So it can do unsubscribe over here. But only one thing you can notice that the subscriber is not requesting data to the publisher, right? Once the subscription happens here, okay, then the data will keep on flowing from the publisher to the subscriber, okay? And the subscriber can cancel it because it has the subscription object. It can do a cancel by using the subscription object and can get itself removed from the publisher in order to not to get data from the publisher. Okay. Okay, so we have kind of seen the reactive extensions, which is first designed to handle asynchronous communications. Well, we'll learn about the asynchronous communication is much more detail in our future part of the videos. But as of now, whatever we understood, in the producer, the data can arise or the data can arrive in any moment. Okay. And whenever the data arrives, it can send it to the consumer. And the consumer doesn't have to block or the consumer doesn't have to wait till the data arrives. Whenever the data arrives in the producer, it will notify the consumer by pushing an update. And that is something that we are talking about from the last few sessions. So I want you to see when reactive extension came first to deal with the asynchronous style of programming, how does that works and what kind of pattern it was. So whatever we have seen, we have a subscriber, we have a publisher, and the subscriber first asks for the data and tries to subscribe with the publisher. And whenever the publisher basically accepts the subscription, it basically gives a subscription object to the subscriber. Okay. But here the point that you have to notice that as soon as the publisher basically accepts the subscription, it basically gives the subscription object to the subscriber. But here the subscriber is not requesting for data to the publisher. As soon as the subscription has been accepted, as soon as the subscriber says, I want to subscribe, the publisher will be start giving the updates. Okay. That's the only difference. There is no request has been made from the subscriber to the publisher that, okay, get me that many data. Subscriber is not requesting the data for the publisher. Now the publisher, whatever the data it has, is going to keep on pushing those data using the on next call. Okay. And that's how it used to work whenever the reactive extension came first. Okay. So apart from this, just like your reactive stream, in your reactive extension pattern, the publisher can give different type of events to the subscriber. Whenever there is an error occurs, it's going to give an on error event. Whenever the data has been emitted, all the data has been emitted, it can give the on complete event. And also the subscriber, as it has the subscription object, whenever it tries to subscribe, the publisher basically sent the subscription object to the subscriber using what the subscriber can unsubscribe, right? So this subscription object primarily used by the subscriber just to unsubscribe from the publisher, right? And I'm talking about the reactive extensions over here, which was the ancestor of reactive stream that we are currently learning. Previously, the pattern used to be like this. Okay, so what kind of benefits you are seeing in this approach and what kind of problem you are seeing in this approach? Let's first talk about the pros. If you talk about the pros, first of all, before we talk about even the pros, this pattern is a combination of the iterator pattern and the observer pattern. Why I'm saying that? See, let's talk about the observer pattern. The publisher is basically pushing the updates using the on next to the subscriber. Okay, so the publisher is notifying the subscriber using the on next call. Okay, just like your observer pattern. And the subscriber is basically handling the events. The subscriber basically consuming the event. What kind of events it is consuming? Just like an iterator pattern. What does the iterator pattern does? The iterator pattern basically consumes elements, right? So here the subscriber basically also consuming the elements. What kind of elements is consuming? First of all, whatever value it is the publisher is giving, the subscriber is consuming that. The subscriber is also consuming other events like on error, on complete. This kind of events also the subscriber is consuming. Okay, so it is also working as an iterator pattern. Maybe this might not make so much sense to you. Okay, the subscriber, okay, you are comparing that a consumer. The consumer is kind of consuming the elements. In the iterator pattern, we used to ask for the data. Here in the subscriber pattern, here in this pattern, the subscriber is anyhow getting the data from the publisher and consuming that. Vilas, are you comparing that with the iterator pattern? Well, if you have that kind of a question, just hold on. It is going to make more sense eventually in next 5 minutes. But just try to understand here that the subscriber is right now consuming the data sent from the publisher. The data can be the updated values or the values which will be asynchronously arise in the publisher. That values might be sent to the subscriber. It can send the error, and the publisher also can send the incomplete method once the data has been sent to the subscriber. Now, what are the benefits over here? The benefit is the subscriber can start the exchange of data at any time. The subscriber can just send the subscribe, it can make a subscribe call, and the publisher can start sending the data immediately. Okay, so the subscriber has the control when it wants to accept the data. One more benefit here, the subscriber can cancel anytime. Upon a successful subscribe happens, it basically gives a subscription object, right? And using the subscription object, the subscriber can basically do unsubscribe. It can make a call to the unsubscribe. Using the subscription object, it can cancel the subscription anytime. Another advantage that we see over here, the subscriber basically knows when the data has been sent, when all the data has been sent from the publisher to the subscriber. How does the subscriber knows about it? Because of the onComplete method. Whenever the publisher basically sent all the data, it can send an onComplete event as well. Okay, and using that, the subscriber can notice, okay, I get an on-complete event right now, so I know that there will not be any further data will be sent from the publisher. If you only talk about the iterator pattern, do you remember how does the iterator pattern works? In the iterator pattern, you used to keep on asking for the data, and let's say if the publisher run out of all the data, after that also the subscriber can ask for the data for the publisher or to the publisher, because the subscriber doesn't know if the publisher has any more data in the iterator pattern. So the subscriber may be making another call to the publisher, and the publisher will say, okay, I'm going to send you null because I don't have any data available right here. In the iterator, we have a pull-based model. The subscriber used to pull the data from the publisher, but here it's just like a push model mostly. If the publisher is pushing, the publisher is going to push an on-complete event whenever it is going to send all the data. And this subscriber is just going to work like a consumer, okay? And here it knows, okay, I get a on-complete method call over here, so I know that the publisher has done emitting all the data, so there won't be any more data coming in, okay? So in this kind of a model, the reactive extension, when it came first, here the subscriber knows that, okay, we don't have any more data available. All right. And one more advantage over here in this pattern is here the latency is less. Why? Because think about asynchronous pull model, just like a iterator pattern. In the iterator pattern, the subscriber need to call for data. It need to ask for the data to the publisher by making the next call. Okay, get me the next element. The publisher will give an element. And the subscriber again will say, get me the next element. The publisher will give one more element. Like that, the subscriber is to keep on asking for data in the publisher. But here we are working on a push model where the data has been pushed. So one important thing that you have to understand here, the data will be arriving here asynchronously. We might get the data at any time over here. And whenever the data arrives over here, it is going to make a push to the subscriber. Right? It's going to make a on next call to the subscriber, and the subscriber will be notified that, okay, now the data has arrived and it can do, or it can react to that and can handle the data. Now, what I want to prove here that the subscriber doesn't have to wait. The subscriber doesn't have to block. Okay, the subscriber doesn't have to keep on waiting for the data to be pushed from the publisher. It is not blocked. It can do whatever things it wanted to do. Right? So the subscriber asynchronously will receive a push from the publisher whenever the data arrives over here. So the subscriber here, here we can see, like, the latency of data processing will be lesser because the subscriber doesn't have to wait. The subscriber doesn't have to make a call to the publisher and doesn't have to wait till the time the publisher will return the data to the subscriber. Here the subscriber can do its own work, and whenever the data arrives over here, it can make a push to the subscriber. Okay? And that's how the reactive extension usually used to work. And whenever the asynchronous communication model first evolved, this kind of pattern, which has been arrived in our tech world at the first time. But what is the problem you see over here in this approach? There must be one problem. One biggest problem that we see, the moment the subscriber is asking for the data by calling the subscribe method, the publisher is basically keep on pushing the data. There is no request has been made from the subscriber to the publisher. Okay? It asks to subscribe, the publisher gives a subscription object, hands it over to the subscriber, then keep on pushing the data. It didn't ask the subscriber that, okay, can I push the data to you? The subscriber didn't request for the data. It kept pushing. So that might be a chance if the subscriber is slow, if the subscriber doesn't have the ability to process all this data, it might go out of memory. There might be a huge chance that the performance between the publisher and the subscriber won't match, or the subscriber won't be able to cope up with all the value that the publisher is pushing. Okay, that's one of the biggest problem that we used to have initially whenever this model first introduced through the reactive extensions. And to solve this, we want a kind of backpressure control. And that is initially evolved with this kind of pattern that we are talking about. And we got another push-pull hybrid model, what we call reactive stream. And that is something that we are learning right now. Okay, so let's just talk about that. So in a reactive stream, we just have the control. As a subscriber, we have the control how much data we really want. Okay, and you know how that works. You are just seeing that, and that's how it works. The subscriber makes a call initially to the publisher by making a subscribe call. The publisher then accepts the subscription, hands over a subscription object to the subscriber, and then the subscriber basically makes a request, right? It first makes a request that, okay, I want this many amount of data. It can make a request over here. This is the long value it's going to take. I want only one element. I want only 10 elements. Just the thing that we are speaking about here. Okay. Maybe the backpressure control that you have seen. Okay. And then the publisher will get that many amount of data. Okay. And apart from that, it basically, can give other events like on error. It also can give the on complete, or if the subscriber wants it, as it has the subscription object, it can also cancel itself. But in this reactive stream extension, that we are using right now, this is something that you are learning right now. This is the evolved. Here it has been evolved. Here the reactive stream has been further evolved, and we got this kind of a pattern, what we are calling reactive streams right now. Here we are basically making a request. After the subscription has been done, the subscription object has been handed over to the subscriber, and the subscriber now making a request using that subscription object. And then the publisher is keep on pushing the value. Now here you can see the push-pull model in action. Actually, you can relate. The reactive stream that we are learning is a combination of your iterator pattern and your observer pattern. Here you can think like the observer pattern is pushing the value. This pushing the value thing has been adopted from the observer pattern. And the iterator pattern, see, the way the iterator asks for the data, right? If you have seen previously the iterator pattern, the way it asks for the data, iterator pattern right here, right? It's basically asking for the data. The client is basically asked, okay, get me the next value. The source will say, okay, here you go. Here you got the value. Again, it's going to say, get me the next value. Okay, the source can say, okay, here goes the value, right? And it might be, this will go in this way. There is also one more pattern, what we call batch iterator, guys. Okay, in the batch iterator, it happens like this. Okay, so whenever there is another pattern called batch iterator, let's say I'm gonna say I want the next 3 value. Okay, this is also a kind of iterator pattern. And here what will happen? The source will say, okay, you want 3 values. Okay, there goes value 1. Okay. Control C, Control V, this is value 2, Control C, Control V, this is value 3. Okay, now you see how does that work? Okay, again it can ask, okay, I want next 3 value. Then it's going to give value 1, then again value 2 and value 3. See, this is what we called a batch iterator pattern as well. Okay, in the normal iterator, we're asking for 1 data, the source is giving us the data. Then the client is asking for 1 data, the source is getting for 1 data, right? But there is another advanced pattern in the iterator pattern where we can ask like, okay, we can ask data in batch. Okay, the client will say, okay, get me the next 3 data. The source will say data 1, data 2, data 3. The client will process it, then again ask for the data in batch. Get me the next 3 data. Now it's gonna get value 1, value 2, value 3. Just same thing we have discussed today in our reactive stream. Okay. So look at this pattern. Here we are requesting for, let's say, every data that we have from the publisher. It can get all the data. But here also we can ask, okay, get me only 1 data. Okay. Then it will only give you 1 data. Okay. And then let's say there are more data. You can again make a request like this. It can again make a request like this, Control C, Control B, put it over here. Okay. Again, you can ask, being a subscriber, get me one more data. Okay. Then one more data will be sent. Again, you can say, okay, if you're going to say, get me 2 data, okay, or get me 2 events or 3 events, then maybe 2 events will be sent to you, something like this. This is 1, this is another 1, this is 2. Okay. So here you have more control. Here in the subscriber, you are saying, first of all, here the advantages is, whenever the subscriber is subscribing, the publisher is immediately not sending the data to the subscriber. The subscriber has to request for the data. It can request for all the data. It can request for the data it wants. Okay. Now it is asking for only 1 event. The publisher is pushing that event to you. Now the subscriber is asking, okay, get me 2 more events. The publisher is pushing 2 more events. Here it is a batch processing. It's asking for 2. Okay, it can keep on asking for 2 in a batch like this, just like I have shown you, right? Let's say this is 1 more event. This is 1. Let me remove this on next so that I'll get some space. See, the data can the data can come like this. It is asking data in a batch. The subscriber is saying, okay, get me requesting for 2 events. It is pushing 2 events. Then again, it is asking for 2 events. Is pushing 2 events, right? It can goes like this. So this is a pattern of reactive stream. In the reactive stream, we have this request control, this backpressure control has been further, this reactive extension, this diagram that I have shown you, it has been further evolved and we get something like this right now. And here we have more control. The subscriber has more control. If it is a slow subscriber, it can slow down the publisher and can demand data as it wish. The amount of data it can process, it can ask for that amount of data. So I have shown you the iterator pattern diagram, like something like this. Okay, here in the iterator pattern, it's asking for 3. Let's say it can ask for something like this. It can ask for 1 event. It can get 1 event back from the source. The client can ask 1 more event. It can get 1 more event over here. Or it can go something advanced like this. Okay. The client can ask 3 events and it will get 3 push from the source. Then again, the client can ask 3 events and it can go for 3 times, right? And we also spoke about the observer pattern, right? Something like this. Okay. In the observer pattern, first we subscribe, then the subject will keep on pushing the data to the observer. And the reactive stream is basically a combination of your iterator and your observer pattern. First, you see, just like your observer pattern, the subscriber is subscribing to the publisher, and the publisher then keep on pushing the events. You can see it's going to keep on pushing the events, but the subscriber has to make a call for this. This is just like your iterator. The subscriber is asking for element, is asking for 2 elements. Then there has been 2 push, but this 2 push has been pushed by the publisher asynchronously. Whenever it has the data, it's going to make this 2 push, right? Just like your observer pattern is going to asynchronously push data, and the subscriber, just like your iterator pattern, is going to keep on asking for data. And also whenever the data are coming like this from the publisher, the subscriber will handle the data. Not only the data, it will also handle the on error and on complete method. So the reactive stream is a push-pull hybrid pattern. It is not only push, like your observer pattern that you're pushing the data over here. It is not only pull, just like your subscriber is asking for data or handling the events like the data or the error or the incomplete event sent from the publisher. It is not only pull or it is not only push, it's a push-pull hybrid model. Okay, that's something that you have to understand. I hope it's making a little bit of sense right now, isn't it? First, this thing has come, right? Reactive extension. Reactive extensions. Okay, I think you see Reactive X. I think this came first. Okay, so if you can go for reactive programming, can I see the wiki? Okay, you'll be learning about the push-pull hybrid model. So you can see Reactive X. This is an API. So this is something which came first. It's an API for implementing the reactive programming with streams, observable and operators with multiple languages like RxJS. RxJava is something that we are more concerned at. Okay. Then the reactive stream came over here. Okay. So, yeah, the reactive stream, you can treat like, whatever we are learning right now is a advancement of this guy, Reactive X. Okay. So right now it has the backpressure control and everything, but initially when it came, I think it didn't have the backpressure control. And that's how the reactive streams are, pretty much good to go for whenever we want to process a huge amount of data. Okay. And we're going to be seeing that in real time, how the data processing happens, right? And every bit of the scenario that you guys are concerned about in our next videos, right? So we'll go into that. Please keep on asking me questions, guys, instead of putting it. Alok, server-side events implementation. Yes, Alok. So we'll bring in those topics in the next session, Alok. Any specific doubts or questions? Yeah.
Got it, Abhilak, but I'll go on, so it will be much more clarified.
Yes, correct. So I just want to show you this thing. There is something called push, that the publisher is pushing the data. There is something called pull. The iterator is pulling the data, right? Now it's a combination of push-pull. The push, the reactive always works in a push way, I told you previously, but there can be scenario when it goes hybrid, the push-pull model. Even if you can go to the let's say project Reactor, okay, right over here. This is the documentation, I feel. So they have some beautiful, description about this. I'll show you one thing. Maybe if you want to read it, you can read it. Introduction to Reactive Programming. Async reduce. 1 second. Backpressure analogy. Maybe I'm going to take some screenshot and we'll send you that. But yeah, don't get confused, guys. Like whoever are learning it for the first time and whoever already learned, please allow me to pass in the things in a step-by-step manner, so that things will be much more easier and smoother to graph. Okay, so I will try to give this slides and everything, maybe within screenshot wise, and I'll just tell you like when will be the next class and what we'll be doing in the next class. So we'll be having maybe 3, 4, 5 more sessions, and we'll have the basic understanding of this reactive, and we'll wrap up, and then whenever we'll start, we'll again go for Spring webflux, which will be the part 2 of this. Okay. But yeah, within 6, 7, 8 session, I think I can pass on a lot of different things to you, and we will bring in the async thing to action maybe in our next to next class. Next class we'll do some other things. Now next to next class we'll be bringing in the async thing. Okay, and we will go through. So far we don't have any understanding what is even the reactive definition and why we are learning this, right? So initial goal will be that why we are learning this. So Alok was asking about the server side implementation and how we can implement all these things in server side. We'll be talking about that, right? So everything on my plan only. So just allow me some time to tell you guys everything. And yeah, I remember all your questions. So whenever it comes, I'm going to pass it on to you. So no worries on that. Okay. Cool. So that's it for today. So do you guys have any other things to ask me?
No, fine.
Okay. So and yeah, I'm sure that lot of you are from out of India, 40% people are from out of India. I'm sure I'm gonna do something, because I'm sure because of the time delay you are not able to catch up. So basically people from Europe. So we'll see. Okay. All right. Thank you, Gopi. Yeah. Thank you, Mahesh. I'll update you about the recordings, I'm planning to give you some initial recordings, so it'll go free otherwise for everyone. Then rest of the things we can continue live who are interested on, and I can record these things for myself and will make it available whenever I feel it's the right time. Okay. And for now, the Reactive is not part of the Spring course. It will not go to your Spring repository for sure. Okay. So yeah. So that's it, guys. So we'll meet on next. Tweet this next Friday, maybe in the next week we're gonna be having only one session, but if I'm gonna plan it for more, like on Thursday, Friday, I'll also give you guys an update. Okay. So that's it. So see you guys on Friday for now next week. Okay. Bye. 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 Thank you, guys. Bye.
Thank you, Abhilash.
Thank you. Bye.